Hello everyone. Today I am going to solve problem 5 of homework 4. So let's go through the question. So question says there are different energy states of a protein conformation. So it's given in the picture. So let's just write it. So there are four energy states that I have already written. So the one is -5, one is -3 kilocalorie mole inverse, one is 1 kilocalorie mole inverse, and the other one is 2 kilocalorie mole inverse. So these all are called as macro states, and each macro state there is some micro states. So we will calculate the number of states are called as micro states from the question, and we can clearly see for -5 there is one micro state, for -3 there are two, for 1 there are again two, and for 2 there is only one. So I just wrote down here, and now we will solve the question. So bit 1 says write an expression for the probability P of I of finding the protein in conformation of I. So that is P of I here is state P of a given state. So we know that from the class that P of a given state is always given as e to the power minus beta into epsilon of I divided by summation of I varies from 1 to j e to the power minus beta epsilon I, and this whole thing is known as partition function or q. I can write it as q, and this whole thing as e to the power minus beta epsilon I, or energy state value, and beta is equal to 1 over kt. Since here we are calculating for 1 mole, we can write it as 1 over RT, and calculating the beta value I got it as 1.6775 into 10 to the power minus 3, and I will use this in further calculation. Okay, so now we got this expression, but we don't know what is value of q. So to calculate q we'll do the same thing, the summation of all energy states from 1 to j. So there are only 4, so I'll just sum them. So e to the power 5000 b, e to the power 2 into e to the power 3000 into beta, and all this stuff I sum. Since here you can see I have multiplied 2 just because there are two different energy states, and same for the 1000, and as always the two different microstates, so it's multiplied by 2, and after solving all these things I'll get my q as 4.705 into 10 to the power 3, and it's a dimensionless value. So yes, now the whole thing P of I will become e to the power minus beta into energy state divided by q, which is equal to e to the power minus beta into energy state divided by 4.705 into 10 to the power of 3. Okay, so next question. Next question says find the probability of finding and protein of energy E. So this is like P of E or P of a particular energy state. So we have to now find a particular macro state, not a microstate. So for that, so we need another formula that's already there in the class, so which is equal to W of energy state into e to the power minus of beta I divided by summation of I varies from 1 to j e to the power minus beta I. So this W is number of microstate in a given number of macrostate, and this whole thing is known as Q. So I can write W e to the power minus beta E divided by Q, and I already know the Q value from here. So that's the way to calculate PE. And the third bit C says we have to solve all these state or find the probability of a particular state or particular energy level. So we'll just use these two formulas that we calculated in first two questions, this one and this one. So let's use it. So first says P of state B, that is P of IB. So this is the simple formula. We can easily write e to the power minus beta into minus 3000 divided by q, which is 4.705 into 10 to the power 3, which is equal to 0.03256 0.58. Same procedure for the next one, but the energy will be changed, and because a state is -5, so I'll write it here again. E to the power minus beta minus 5000 divided by 4.705 into 10 to the power 3, which you will get 0.9334. State D, e to the power minus beta, state D value is 1000 over 4.705 into 10 to the power 3, which is equal to 3.97 into 10 to the power minus 5. You can notice one thing: if the energy level increases, the probability decreases. In the mean, that means the lower energy level have a better probability, and that's always satisfies our thermodynamic rule. The next thing is probability of energy level 1 kilocalorie mole inverse. So we have to calculate the energy level, and we have to use the second formula, which is this. Now I can write for 1, I have to check how many states, because W is the microstate. So I can see for 1 there are 2 microstates, so I can just write 2 into e to the power minus beta into 1000 divided by 4.705 into 10 to the power 3, which is equal to 7.95 into 10 to the power minus 5. Same for minus 5, but here W is 1, so 1 into e to the power minus of beta into minus of 5000 over q, which is 4.705 into 10 to the power 3, which is equal to same value for the state 0.9334. Okay, so the next question says, what is the average energy of an interval of conformation? So we have to find average energy of the particular state, which is known as this, and we know expectation of any value is always equal to this, or we know expectation of x equal to summation x p of x. So we just wrote the simple formula, and we know from the previous answer that p of I is always equal to this. So now we can write the simple formula for all the states, and there is no calculation for no microstate. Always the calculation is for macrostate, so I don't have to multiply the microstates. So I can write minus 5000 into e to the power this, minus 3000 into e to the power this, 1000 into e to the power this, 2000 into e to the power this over q. And if I just put this in calculator, and my q is equal to 4.705 into 10 to the power 3, if I put everything in calculator, I'll find this is 46.865 kilocalorie mole inverse. So the average energy value is 46.865 kilocalorie mole inverse. That's all. Thank you. Let me know if you have any doubts.